Let's do another theoretical yield problem. We're doing stoichiometry. If 18.4 grams of methane is combusted with an excess of oxygen, what is the theoretical yield of each product? So we're doing a combustion reaction. Methane, which is CH4, plus molecular oxygen, which is O2, reacts to make carbon dioxide and water. The balanced chemical equation places the coefficient 2 before both the molecular oxygen and before water. What this is telling us is that 1 mole of methane reacts with 2 moles of oxygen to make 1 mole of carbon dioxide and 2 moles of water. Or 1 part methane reacts with 2 parts oxygen to make 1 part carbon dioxide and 2 parts of water. So in all of these, we're doing grams to moles to moles to grams. We're using molar mass whenever we're converting from grams to moles or moles to grams. And we're using our stoichiometric ratio whenever we are converting from moles to moles. So first let's do methane to make carbon dioxide, and then we'll use methane again to predict how much oxygen that we have. And that we've got the unknown amount of methane, and we've got more than enough oxygen to make the reaction go to completion based on methane. So 18.4 grams of CH4 methane, 1 mole of methane, it's the same as 16.0 grams of methane, 1 mole of carbon dioxide, it's the same as 1 mole of CH4. That's our stoichiometric ratio from our balanced chemical equation. This is 1 mole methane makes 1 mole carbon dioxide. And then we want to cancel out carbon dioxide, so 1 mole carbon dioxide is the same as 44.0 grams of carbon dioxide. Gram CH4 divided by gram CH4. Mole CH4 divided by mole CH4. Mole CO2 divided by mole CO2. That gives me grams CO2. It'll be 50.6 grams of carbon dioxide. Then we're asked what's the theoretical yield of water. We want to know what was the theoretical yield of each product, of both products. So now we're going to do the same thing again, but we want to wind up with moles of water. So 18.4 grams of methane. 1 mole of methane is the same as 16.0 grams of methane. That way my grams methane cancels. I've got moles methane. I need my stoichiometric factor that relates moles methane to moles of water. And if I look at my balanced chemical equation, 1 mole of methane produces 2 moles of water. Moles methane cancels. Now I need to convert moles of water to grams of water. And it's 18.0 grams per mole. So moles water cancels. That gives me grams of water. And that will be 18.4 divided by 16 times 2 times 18 is 41.4 grams of water. We could find as an extra step how much oxygen was consumed. And we could do this by doing the grams to moles and moles to grams, but let's do it using the law of conservation of matter. That my grams reactant has to equal my grams of products. Grams of reactants have to equal grams of products. So I've got 50.6 grams of carbon dioxide plus 41.4 grams of water. And that is equal to 50.6 plus 41.4. That gives me 92. Yeah, sorry about that. 92 grams of product. I'm going to subtract from that my 18.4 grams of methane. And that'll give me 73.6 grams of oxygen. That's how much oxygen was actually consumed. We can check that doing our stoichiometry method of grams to moles, moles to moles, and moles to grams. In that I've got 18.4 grams of methane. 1 mole of methane is 16.0 grams of methane. My stoichiometric ratio, 2 moles of oxygen per 1 mole of methane. Grams methane divided by grams methane, moles methane divided by moles methane. And the moles oxygen, and a mole of O2 is 32.0 grams. So I can cancel my moles of oxygen. 18.4 divided by 16 times 2 times 32 gives me 73.6 grams. Yabba dabba doo. Let's do one more part of this problem. What is the percent yield if only 22.5 grams of carbon dioxide are recovered? What's the percent yield if only 22.5 grams of carbon dioxide are recovered? So percent yield is equal to actual yield divided by the theoretical yield times 100%. Our actual yield was 22.5 grams of carbon dioxide. We said that our theoretical yield from the previous page is 50.6 grams of carbon dioxide. So 22.5 divided by 50.6 times 100 will be 44.5%. That's my percent yield.